All right. Yeah, welcome back to another TouchDesigner Meetup. This one is going to be on Kinetics. And yeah, as Greg just said, it's the 30th one I'm doing. So it's actually an anniversary. And yeah, a really lovely one, I think, with this lineup that we have. And
Mm. And
um,
um, and just to prove that it's your 30th, I put a link in the chat about the playlist of all the Music Hackspace sessions that happened over the last couple of years.
yeah, definitely
So check that out.
check that out. And we will also record this one. So it will show up there in the next days. Yeah, so we've been doing this for 4 years now, which is crazy. So we're gonna be talking about kinetics. So it's really about moving TouchDesigner into the physical space and not just sitting in front of your computer, but really like working with physical objects in space and making them react to their environment and to external input and connecting TouchDesigner, yeah, to the physical. So it's gonna be a really interesting one. We've got three different presentations, I guess. So we're gonna start with Lumus Instruments and Boris Acket. So like Timo Lejeune and Boris Acket, and then we're gonna move over to I'm not sure which one is gonna be the next actually. Either Volvox Labs or Patrik Lechner. Let's see. So yeah, as usual, we're just gonna go one after the other, the presentations. So if you have any questions, feel free to just write them down, and then afterwards, after presentations, we're gonna move over to the meetup room one, and then you can ask all your questions, and after that, we can just have a free and open chat about anything TouchDesigner or whatever is on your mind. So yeah, feel free to write in the chat where you're from. It's always lovely to see, and we got a huge crowd today, which is also great. And yeah, my name is Piliam. I will be your host for today, and yeah, I'm really excited to do this. So I think without further ado, we can get started with Boris and Timo.
So yeah, maybe a little bit of an introduction what we want to talk about because
Yeah.
we always we collaborate a lot and we always have like a lot of interesting discussions about why we create these physical objects, why we want to make physical things, and like the software is really like kind of a big part of the hardware, but it also really goes together in one way. We're not really like really software focused or really hardware focused. We try to find this nice combination. So that's why we wanted to talk a little bit more about like our thought experiments, like how we approach these kinds of things, and we can go a little bit more techy in the end. So yeah, maybe we can go to the next slide. And I am from Lumus Instruments. My name is Timo, and I run the company together with Julius. And we do a lot of physical kind of installations, a lot of custom things that we try to make, a lot of like modular kind of constructions, and that we control in various ways. Now maybe Boris can introduce himself a bit.
I'm Boris. I'm an audiovisual artist. My background is very much in sound. I always started with composing, and my first experiments were also like more in the spatial speaker sculpture realms. We'll touch upon a theme like fairly soon in the presentation, which really fueled that and fueled like a whole array of ecosystems and stuff that I worked on. And me and Timo started collaborating, I think it's already 5-6 years ago now, through their love for like custom lighting, both in hardware and software. And I think, in this presentation, we will also get to that, like we have a very special synergy together when we co-create. But yeah, let's just get into it, I would say, right, Timo?
Yeah, let's do it. So I think what we want to explore is like how do we craft these physical systems as instruments and search for the essence in their form. So one thing that Boris and us really talk about a lot is like how can we create kind of instruments that we then play with. So every kind of installation we see like what is essentially the system and how can we make this in a way that that you're invited to explore essentially. So yeah, maybe we can go to the next slide.
Yeah.
So here's a little bit of an overview of what we want to talk about. So first, we're going a little bit into philosophical grounding. Then we're going to talk about anger and actualization, which are two installations that come from the same kind of hardware environment. And then a little bit about the hardware that we created for that, and a little bit about the software. So I'm going to take it for a little bit in the beginning, and then I'm going to give it to Boris, and he can take it away with his crazy stuff. So one thing that I thought was really interesting is I stumbled upon some philosophy of Aristotle about the anima, which is the translation for the soul. And in this thing, he talked about matter and form. And I think we also often really approach like matter and form as something really constructive or kind of dead. And within the anima, he argues like how this kind of dead matter can essentially get a soul, and how does that then become more real to us? And this is something that we often question ourselves in these installations, like, why are you making this? Why are you just heaping up atoms essentially and putting stuff together, and then it has to become something? But when does it start to feel authentic to us? So essentially, you can see a chair as a functional kind of thing, or you can see it as a piece of wood. So when does it become the chair? That is essentially the question. Can you go to next slide? This is really good voice recognition.
What?
Really good voice recognition. Like next slide.
Yeah. Bit of a
So
delay, in there.
Yeah. So there's this professor from the University of Toronto, actually, and he really talks about the philosophy of Aristotle in a nice way. His name is John Vervaeke. And he also pointed out, like, there's actually, when you're talking about movement and about kinetics, you can see something interesting in the word actuality. And this is also an interesting point of where we stumbled upon making actualization. It's like we talk about actualization, like making something actual in the world, like is it actually real? And at the same time, it also means movement. It means like you act upon something. It's the way you move and the way you act upon the world eventually makes how we see this kind of object. So it's essentially like the animation of the object is the way how it speaks to us and how it makes something more real. So this is, I think, also something really interesting what we explore in these moving pieces, that like when does this spark happen, that we look at it and we see like, oh yeah, this is essentially the essence of that piece. Can you go to the next slide? So this is the professor John Vervaeke. I can really recommend watching his series called Awakening from the Meaning Crisis. And so he talks about this kind of form, like what is the essential form of then, for example, a chair. And he talks about this as like the structural functional organization of that object. So a lot of times when we create these kinds of objects, I ask myself, like, what is the structural functional organization of the form? Not per se the shape, but like the combination of all of these mechanical elements. And then how can we translate that also into a software that nicely reflects this kind of form? And because we want to approach everything in such a custom way, you have a lot of freedom in like creating this kind of mirror image of like the physical thing and the thing in software. Can you go to the next slide? And so Joscha Bach is another really inspiring person, especially in the field of software. So I think he was also a conceptual theorist at Intel for a long time, and he's doing a lot of work and philosophical work in AI. So for all of the software noobs, I really recommend hearing his talks. So one of his latest talks is called Cyber Animism, and in this he also describes as like, you know, software is essentially also just a physical thing. You know, it's a causal pattern. It's like a pattern of atoms that creates a cause. You know, that creates actually a kind of behavior. So I think that's also a really interesting way to see also software as like it is a kind of physical part of the hardware environment. And I think it's interesting to see like how can these two fit together, and how do you search for the essence in that stuff and not try to overcomplicate everything. I think this is also what motivates these people to to really find this kind of essence in the form and try to express that in how it is animated essentially. Next slide. I think now it's so to wrap this part up, and then Boris can take it away from there. So essentially, during the creation, I'd like to ask myself like, what is the form? How is it structurally organized, and how should it act? And then you start to create a system around it. But I think it's not. It's nice to not try to overlook it as some like very a basic or banal thing, to really try to get to the essence and the core of this system, and then explore that essentially. So now I think Boris
I
talk
think
about these two
actually
beautiful people.
I want to first talk a little bit about Gordon, because it really but I like Gordon Hampton is an acoustic ecologist, and I worked with him for some time now. We're continuously still doing projects, and what he really taught me, I think, about the works that we make is he's also pictured here with a microphone, which is basically one of his favorite listening exercises. I don't know if you guys ever do field recording. Like I did quite a lot of extensive field recording back in the day. And I think the installations that we do, or like the click that you look for, is very much hidden in one of the examples that Gordon always poses about becoming a better listener and how to get a better listener. He always says like you grow up as a kid listening to quote unquote unimportant stuff like cars and voices and teachers and alarms. Basically all the stuff that we brought into the world, and we forget how to listen filterless. And then if you put a microphone on the world and put the headphones on your ears, and you put the world a little bit louder, like 2 or 3 dB, you are able to listen without the filter again, because the microphone doesn't have a brain. So it will just let you listen to the world without a filter. And I always like to look at the works that we make as this microphone. Like if you make the right work and if you make the right click, it often provides this very beautiful insight or enlargement or slightly different perspective on something that you already know, and you can sort of reconnect to it. So I think that also really touches upon the example that Timo just, or like the philosophical grounding that Timo just sketched, out of like getting really to the essence of a form, basically a microphone enabling you to be a kid again and listen, is a very beautiful example of such simplicity to me. And the second thing that I just wanted to throw in there, because to me, that's like an essential thing when we go about doing these works, and especially also in my own practice, is that my own practice is quite melancholic, and it's always about memories and about time. And you have this really beautiful book by Jimena Canales, which is called The Physicist and the Philosopher, and it's about a conversation between Einstein and Henri Bergson, a physicist and a philosopher, in 1922, and they have this conversation about time. And the Einsteinian view is really about like we are clocks, and we should use clocks as calculation tools. And I'm just going very like you should read the book when you want to go deep into it. But the Bergsonian view is much more subjective, and he basically argues that to get to understanding the human experience of time, you really have to add another layer to the equation. You cannot only use time to calculate, because basically the only thing that we have and that we can share, like this moment that we have right now, is the now. There is basically not much else. So you take your memories in this moment and your expectations, also the expectations of our beautiful presentation that we're doing, to also be able to listen to us and to get to the next moment and the next. And I really like to take this into account when making these installations. People can walk into an iron forest with LED panels and think that they are listening to crickets or whatever. And the only thing that enables them to listen to crickets while you're actually firing the most digital stuff at them is because they take their memory into that moment and their association. And I always like to design with that sort of notion of time, because memory, time, and melancholy make for better works, I think. So that's just a brief thing that I wanted to say. And then in this work that I will just do the conceptual part now and like take you a little bit in the way we started developing this conceptually, and then Timo will take you into the hardware side, because for Einder, for the first iteration that we did, we created both hardware, software, and the conceptual part. But in this specific iteration that we see right now here in pictured in Berlin, this was also very apparent. So this piece is basically a piece of fabric moved by 18 linear actuators, only back and forth. And people visiting this work really came back to us with the wildest associations and childhood memories when they were looking at the work. And basically the whole Einder thing, I will try to play this. Yeah. This was the first test that we ever did. You see here in the top this cheeky linear actuator that is actually not really moving the fabric yet. It's going like 30 centimeters back and forth. But we found this amazing microscopically knit glass fiber fabric that basically eats up light that you shine upon it, and that enables light to travel through it when you light it from the back. And we were very enthusiastic about like working further with this fabric, and like together with Lumus instruments, like Timo and Julius came up with the idea together with me to create these linear actuators that you see here pictured on top, and he will get into those mechanics pretty detailed in a sec. And then the result of this movement looks like this. And basically I was hearing myself talking in this video. I'm sorry, that was very distracting. Basically what you're seeing here is the fabric moved back and forth by these linear actuators that get fed by a TouchDesigner patch. And what really became a very interesting another layer in the work is the juxtaposition between control and surrender. When we were looking at this thing, we were continuously also asking ourselves, like, why are we going to such lengths to mimic something natural? And there is a very interesting thing in humans trying to control things, but always also have to surrender to like certain properties of their environment. And I think very intrinsically interwoven in this work is this juxtaposition between control and surrender, as in we can never control the fabric fully. We can only parameterize it, and then every wave will act a little bit differently. And if you will leave it here for a week, it will slowly start looking differently. And I think in a sense of like using TouchDesigner in physical space instead of only on your screen, this really adds this very interesting layer, because I think that if you would zoom into this, you would also see animations that you would like literally be able to create with a TouchDesigner patch as well. And then I will start moving a little bit faster now due to the time, but then we started just like enlarging. And this was an iteration of 30 meters long at the Lost Art Festival in Berlin. And that looked a little bit like this, where we could use like the full length of the space, being able to animate like synchronously with light and sound over a length of 30 meters with 18 mechanisms. This one was in Berlin for a solo show that I presented in Cool House together with the Dark Rooms exhibition. And what I found really inspiring of this process is that we, in essence, don't do very, very complicated stuff. The material and the way we hang it, and then like the very simple interventions, they make it complex. So, for example, here we are all of a sudden using ventilators with a quite known technique of using pulse width modulation to create like smooth transitions in wind. You can literally like very precisely put the fabric into an angle by using pulse width modulators to use ventilators. And I think what is very inspiring about this specific iteration, I will just play it again, is that you can, like, I encourage everyone to just like start very simple, because it will give you so much to like take a piece of fabric and something that already moves when you plug it basically into a dimmer, and then start like making that into a system that you can further parameterize, is just a very interesting thing to do with TouchDesigner as a base. The most complex iteration we did yet, I don't know if he's here in the group, but we did it with Corey and with Kling Klang Klong from Berlin, made like a super collider patch that was able to generate 3 storm cells that traveled in and outside of this space. And we brought that control surrender thematic to a whole new level, in a sense that we could only animate top level parameters, the position of the storm intensity, and then the fabric and lighting would react as a thunderstorm would do that would travel through this building. And you can see also in this animation here that we slowly get to a way better understanding of what the fabric is doing with the air that it pulls and with the free space that we give it to float. And to me, it's just really interesting to see how this work continuously gets different. And then I think this is the last one we were showing for now, is that this is one that we came up with and this is also, I think, a very big part of our practice, is the play in it. When we were presenting the one with wind in Berlin, Timo and me discovered that separately from each other, we were running past the fabric with our coats next to it. And then because you make all these instruments, you're like, okay, how can we parameterize that? Well, let's build a fucking wing and not run, but like let's move the wing past the fabric and start using wake turbulence to animate the fabric with this wing that we can also control with a tilt. Basically, I think the takeaway that you should get from this summary of iterations is that it gives so much satisfaction to like slightly change the parameters and create these very essential movements. Like this is only back and forth and a wing that is able to create wake turbulences with one turning mechanism. And then all of a sudden you have this work in a hallway that generates wind and this beautiful motion and has all these different perspectives on the architecture. And it's all about play. So yeah, I think that is my part for now. Timo, I will give it back to you.
Thank you. Wonderful. You said it very nicely, Boris. So thank you for that.
Thanks.
I think I just want to briefly touch upon actualization, because I think it is a really nice example of we created this slider element as a kind of modular system. You know, always when we make something, we want to make it something in a way that it's easy to use, that it's durable, that's, you know, it's not thrown away in the trash bin essentially after you use it for the first time. So that is how we came up with like reusing the sliders for an installation called actualization. Maybe you can go to the next slide. I think there's a movie.
Yeah.
Next slide again. So this is the first iteration that we did at a exhibition in the Netherlands called Radiant Voids. And here you again also see it's just a very simple kind of movement. You know, also you stay in that space for a long time with the installation, and yeah, I tried to make a various amount of like movements and segments, but still the thing that works the best is just put a very simple sine wave on the system and let the lasers follow it, and then you get these really interesting and nice shapes, and then again it's like really close, I think, to the essence of the work, and also how this kind of repetition, I think that is also really a big part of our DNA, like making one thing in a way that you can make multiples, you know, always working with these kind of multiples, because when you have multiples you can create like delay change, you can create interaction between the two pieces. And I think this is also something that we often try to do whilst already developing the hardware, like try to develop it in a way that if you make 20, if you make 50, if you make 100, it still works, you know, and you can use it in relation to each other, essentially. I think the next slide shows actualization 2. Actually, this was, yeah, we can play it, but it's essentially a different form around version. This was presented at Monopol in Berlin with the wonderful Jose.
I think one nice thing to
Yeah.
add, I don't know if you might forget, is like, I think what is also again nice in this piece, and it's also within the fabric, is that you have the laser, of course, materializing in smoke, but also the mirrors that have like a slight hue that changes the color, which is also present in the fabric. So you have a very digital controllable layer, but also there is something happening here which you cannot fully predict or control. I just wanted to add that physical coloring is very interesting.
Yeah, and just that you have the reflection, this physical kind of elements, like, you know, the angle of what the laser points to the mirror and how it reflects it. That angle just creates very interesting shapes in itself. So also just using that as a kind of like real world computational thing. You know, you can simulate these things in software, but you can also just do it in hardware. So now briefly we can take a look at the sliders. We can go to the next slide. So here I just found some really early pictures.
Nice touch, nice and homely.
Yeah, we always design our sliders on the couch. But I think the first thing when we started to take a lot of time to select the right kind of materials to start work with, like how do you decide to invest in something like that? So also here we investigated a lot of different like options of using like 3D printer profiles and make the sliders ourselves, blah blah blah. But in the end, then again, you ask yourself the question, like, how much time do you have to invest in creating the hardware, and how much time do you have to want to spend using it? You know, because I've also seen a lot of cases where you've spent so much time on creating everything custom, and then it works, and then you're troubleshooting all the time, or like there's stuff wrong all the time, and that takes away from your creative process and actually putting it to use, because this is in the end what you want to do. So the selection of the slider, of the actuator slider and the motor was a really big part of the process. This combination is essentially what we ended up with. And then you go to the next slide. And then we essentially built this case around it, so it looks nice and sleek, so it's protected, that we have the right connectors on it, and then we can attach truss clamps on it, so it's just really easy to use. You know, you can put it in a flight case, you can just handle it, put it up, and yeah, we really believe in that this is a very important part to spend time on, because then you make these things durable and you want to use them for it becomes again a kind of instrument to play with instead of a piece of technology to break your head over all the time. We can go to the next slide. And here you see, yeah, how it eventually got finished in the black powder coat. So we're really happy that also in the end results in these sliders, they really become a part of the installation, but they're also on the background, you know. So it's not like, oh yeah, here's this piece of equipment that is moving the fabric. It has a little bit of this mystique because it's just a black beam with a stick coming out that goes in both directions. And it's also a beautiful kind of object. So we also think that this is, yeah, it really adds to the end result. And so this was how it was installed at the Lost Arts Festival in Berlin. And I think
Yeah, I
now
think I would like to I would like to add that
Yeah.
it's always nice when you exactly see from the minute you walk in what the mechanic is, and then still are able to look at it for 45 minutes. I think that's also when it clicks.
So yeah, here you can just go to the next slide, but we can, if there's still a little bit of time, but maybe Billion can say if that's a good thing to do. I can try to share my screen again, and I can walk you through a little bit of the software chain that we use.
Yeah. Shall I
because
close
was
this?
also- Okay, so then I'm just going to talk a little bit about it. So we always use a combination of Ableton, TouchDesigner, and usually Lejenue. So within TouchDesigner, we try to create these kind of elements with parameters, essentially a little bit what Boris also said about how they approach the storm. Like we spend a lot of time really deciding, like, you know, what are the parameters that we want to control. Like, you don't want to have too little control, but you also don't want to, you know, you can control everything, but we also like that's yeah, you create this kind of system that you can again play with. So I am usually more on the seat of like, okay, what are these kind of tools that we play with? Boris is usually on the Ableton side, which we use as like a really good timeliner tool, but also of course for all of the audio and more fun stuff. And in this way we can really nicely parallel program. So I make these kinds of tools that control all of the movement, etc., etc. We both connect them to Ableton, and there we take care of all of the timeline, but we also just play around with it and looks how it's sees how it looks. And we used to just do that over OSC, just put in a lot of like OSC send plugins and just get it to TouchDesigner to control these things. But it's essentially just a lot of different kind of patterns, or what I personally like the best is just an LFO with a trail behind it and controlling the trail in a nice way with stretches and with trims. And yeah, just if you grab the right kind of connectors, or if you grab the right kind of parameters, it works really well. But why I like the trail the most is because it's essentially a software replication of the fabric itself. Because this was also this interesting talk that we had where the fabric itself is essentially one big lag / trail instrument. You know, you push it on the top, and then, you know, it slowly floats around the whole fabric. So in the software, this is also mimicked by, you have an LFO and it essentially just trails through all of the mechanics. And if you start to control the LFO, then it again has this kind of flowing out. It has this laggy delay kind of function on the rest of the mechanisms, and how this like keeps on flowing while you're changing shape. And so it's not like, oh, let's try this shape, you know, and it goes to that shape, and then let's try this, and it goes to that shape. It's like this kind of system that you like slowly parameterized, and it's like slowly shapes and forms. And yeah, I think the biggest back in the day technical challenge that we had is that you just have these two sliders and you have this really thin piece of fabric behind it. So you didn't want the fabric to like the two sliders to go all the way across from each other and rip the fabric. So to solve this, we using a dot system, we just calculated like what is the distance between the two sliders. So that's like if the virtual distance is too much, it automatically limits itself, that it doesn't rip the fabric apart. And I think that is a really beautiful kind of example of the power of TouchDesigner. Like, you can use MatMapper or Lejenue or whatever to create these kind of shapes, but to build in this kind of security structure that's it always controls itself essentially, and that you have this kind of surgical kind of precision that really allowed us to really play with it without thinking, oh, maybe we're going to break something, you know, because you want to be free to explore and not be like, oh yeah, but maybe if we try this button, then it will go like this and it will rip the fabric. So I think that was a really nice kind of software solution to, again, allow for us to just play with it and to not break our head on the technology and the physical sides. Yeah. Is there anything you would like to add, Boris? I think this is essentially a little bit of the overview that we wanted to give. I hope it was insightful, and if people have questions on the software side, like, I'm happy to share it with them. But I think essentially what the software side, it's not really super software heavy. You know, it's quite simple, elegant programming. But especially like how do you combine these two things in a nice way, and also like how do you create everything that it affords you to just play with it and experiment with it. I think this is really something that we want to focus on.
Yeah, absolutely beautiful. Like, and also just saying the simplicity, like, I really love that you're moving the fabric and therefore kind of using the power of physics to, and you know, you don't have to like program like randomization into it to make it look organic or something. You're just using a fabric which is by itself moving organically. So I really love that connection and so sort of the surrendering to the physics. There he is.
For sure.
I'm
and
back. Okay.
the memory, time, and melancholy. I really like that that little philosophical share there. And also, I have to say, I mean, having seen those pieces live, either as the vertical piece, and also the storm, that it's really so hypnotic. I mean, you can just stay and experience that for a long time.
Yeah. I just wanted to say, like, what I really like about the collaboration between me and Timo is that, for example, we try to look at thunder, for example, not as something that will exit your speaker as a stereo thunder, but then also really questioning what is the source of the thunder. Can we then recreate the thunder? Can we then, for example, trigger it from a 909 kick even, then with some LFOs and filters that are continuously generative and some delays that are continuously generative? Can we feed that thunder into 16 other channels? Can we use those 16 other channels to divide that over the speaker system? And then can we use that input to create a thunder effect in TouchDesigner and on the fabric that will create both movement and light, in which we basically one time make the thunder engine and then it afterwards just triggers a thunder, you know? And I think I really like that versus just timelining a fabric as a film.
Yes. So also maybe to translate that a little bit into like software. So for example, what you're saying is you have 16 instances of something. You have 16 instances of actuator, you have 16 instances of speakers, of lights. And in all of these different software programs, we create like these 16 instances, then for example, can be whatever number, and we try to match those. And this becomes this kind of system where you can easily like connect everything and it correlates to each other, you know. And this is where it really becomes like this one singular kind of machine that can only work in one way, essentially. And that's, if you control something, then everything else automatically responds, you know, because it's not, it's really built to be this one singular thing together.
Yeah, so it must be sort of a variation of where you're kind of building and tweaking the instrument and then kind of playing it, and then you get to another point where you have to tweak the instrument further, and then you play it. So you kind of back and forth a lot. Once you get the flow of it actually working for the first time, then the playing increases and the tweaking and redesign decreases until you kind of get into a good space that you want to be.
Yeah, and it's also then really nice the part that these physical pieces start to play, because they're really this kind of actor in this whole kind of back and forth, and you never can fully predict the outcome of how it will act, you know, and how it will look. So it's really a part of this kind of playing session. These weird robots. Yeah.
Thanks a lot for presenting. That was beautiful. Boris, are you going to stay a bit, or do you have to bounce?
I unfortunately have to bounce to the montage again, but thank you so much for having us. It was very nice to speak to you. And
likewise. Thank you
I
for
think
joining.
Timo will stick around for a bit, so I hope to see you guys soon.
Okay.
And
Good luck with the montage.
Yeah.
Thanks, Boris. That was great. Thank you.
Cheers. Thank you so
Bye,
much.
Boris.
Bye.
All right, so we will continue with more presentations. If you have any questions, I already saw a few in the chat, then please just note them down and you can ask them later. For now, we will continue, I would say, with Patrik. Is that okay for you?
Yes. Hello.
Right.
I have not prepared a presentation, lack of time, but I see this more of a like a open studio situation, if that's okay for you. I would like to show you two projects that I did in the past, or one of them is very much ongoing. The other one might go on. We will see. I think I would like to start with the project where I expect less questions and where maybe it's not so interesting to dive super deep, and then move on to the other one. So the first project I want to tell you about was a cooperation between Matthias Granebitter and Christopher Sturmer and me. It's an opera project. And I will share my screen in a second. But before I do that, I wanted to show you the little devices we were exploring for this project. Here you can see one of them. It's called Marvel Mind, or the company is called Marvel Mind. And these are little trackers, basically 3D trackers, that work acoustically. And I would like to share my experiences with them. I think they have all kinds of interesting pros and cons. And maybe they might be interesting for one of your projects. For me, in hindsight, I'd say for me they were not the right choice, but sometimes it works like this. Let me share my screen. So here we are, I think. You can see my screen, I hope. Get rid of this. Thank you. So I'd like to quickly show you basically the result of what I'm talking about. So this is, it was an opera project. One thing that's interesting about this kind of projects is I think that, I've had a couple of cooperations with ensembles and orchestra pieces. And one problem always for me is, there comes a composer or an ensemble says, okay, we would like to, cooperate on this. And I always say, okay, when can I hear the music, And that's always a big problem. Like it's finished often during the rehearsals, right there. Right? So that's quite a challenge. I will quickly show you a part of this performance, basically. But here in this screenshot, you can see these little thingies standing on these boxes. So Matthias Granepeter was the composer of this thing. Christopher Sturmer and me kind of did the stage design. And these boxes were basically moving around, and I attempted to do some dynamic 3D mapping. In this screen, you can see it's not absolutely not flawless, but still, it got the effect kind of across. I'm not sure. Can you hear the music? I mean, it's not super important, but yeah, okay. So, I will not let this play much longer. The whole thing is on YouTube. You can watch it. Let's see, maybe we'll find another interesting shot there. But you can see this stuff is moving around. You get the idea. So depending on like our audience, how interested you are, I can go deeper on the experience. But I would like to straight away jump into the software side of things. Let's see where we have this. Basically, these are two TouchDesigner projects that I was using here. One was basically just the tracking and the error correction. Like this kind of system, again, it works acoustically. So these little things send little impulses basically and triangulate each other. So on these boxes, I've put I think 3 or 4 of them per box. Let's see if one can see it here or somewhere. Well, it doesn't matter too much. But you can imagine on each corner one of these things, and they like to drop out. They like to lose their connection. Also, if they don't have basically line of sight, let's call it, although it's about sound, it's you basically lose them. So there was a lot of error correction going on and pre-visualization, etc. And this is what this patch is about, basically. I've made a little interface where I can see the IDs of these things, what's their signal strength, if the batteries are empty, etc. Generally speaking, it's an interesting system. I think one of the real advantages about this system is that it's very scalable. Like this system, you can use it in huge areas, like kilometers basically. If you put in enough money to have enough of these beacons, etc. So this seemed like an advantage, like scalability. This little patcher then, or this network, sends its information over to the actual show network that you can see here. And here I made a little, basically, pre-visualization thing also for internal communication. Like somewhere on the web I have a video of the whole show with this pre-visualization for internal communication purposes, basically. But you can see that stuff is supposed to move around, and it moves around a little bit, and this all doesn't work correctly right now because the stuff is not connected, etc. So that was a very interesting project. We learned a lot here, I think, especially about this scalability issues and connection issues, and it was a big team, many challenges. at the venue also, and not a lot of rehearsal times. You can imagine that, having these huge cubes that we custom built, standing around in some venue with the orchestra, etc. You don't get a lot of time to actually try out the whole thing as it will be on the stage, right? Musicians cost money, etc. So that was quite a challenge, and it worked out, more or less. So I would now switch to the other project I wanted to show you. Before that, this is the composer, and this is the stage designer we worked with for the other project. The second project is called Rota. We have been working on this since quite a while now. We first presented it at a residency at SAT in Montreal, where we did a dome version of it. And when flying back from Montreal, we basically realized that this piece works not as well without a dome. So we have to come up with some interesting ideas. And we started projecting onto this structure that you can see here. Here's a clearer picture. And I've actually have it standing around over there, and I will show you in a moment. But basically what we have here is a custom-built rotating speaker with some light systems and coaxial speakers in there. And we project on it. It can spin very fast. Spins at about 3 revolutions per second. But since, if you look at it, you have these 4 cones, basically. So it gives you the impression of a faster speed because 4 times per revolution something, goes by you. Can be a little bit windy, a little bit scary, which kind of makes it a very physical experience. Let me show you. Here you can see basically this thing moving around and projecting. And I think from this little snippet, you can already imagine the kinds of tricks this machine can play, right? Like, if you just have a 3D model of the thing itself and you don't rotate the 3D model, but this thing rotates really fast, you get some weird impression of, maybe it's not moving, etc. And similarly, when you start strobing it in speeds that are kind of related to the speeds of actual rotation, you also get the impression that it's not, or it looks like it's not moving, but if you're close, you feel the wind and you also kind of see that it's moving. So it plays tricks on perception of speed, basically, and that's what we are very interested in. I will talk a little bit more about the construction of this machine and on the software side and how this communicates, etc. But quickly to give you an overview of the team, this is Matthias Lenz. He's basically our construction engineer and an actor and performance artist. And Peter Kutin is responsible for the conceptual side. He also had a previous piece that he worked on where it was very much on rotation. And he is responsible for the sound. And he also now just released an album that he made with this with the sounds of the rotor that you can find here on Bandcamp. Also, we made a movie that is that is available via Sixpack Films. Let me maybe talk a little bit on the construction here. So we have this motor in there, of course. The motor, interestingly, causes us to, every time we play with this piece somewhere, ask the venue for 2 different power supplies because the motor actually seems to send some spike through the power systems when you start it. That caused us quite some trouble in the beginning because we didn't realize this. And the power spike causes some very weird problems sometimes. Like we had problems, like during the sound check, everything was working wonderfully. But as soon as we started the motor, the video projector would stop working. And then later it would reconnect. So very odd, almost esoteric seeming problems would start to come up until we realized that giving us a second independent power supply would really, save us some trouble. We have this motor that turns this thing, and we have a sensor that is attached to the blades of the cooler, actually, of the motor, and we are basically getting out like I think 100 impulses per rotation of the whole thing, and one impulse on another channel per rotation. So we always can calculate the position of this actual thing. This runs via two jack cables to my computer. And on my computer, I have this little Max patch here that hopefully, we tried it before, but I'm still skeptical, hopefully won't mess up the audio when I activate it. So this is now getting my microphone in. But usually you would get the impulses coming from the rotor, and it would estimate the position of the rotation. Actually, what it actually does is it actually tries to predict the position of the rotor. Here you can already see that this project lives since quite a while, and at every iteration where we play, different ideas come in, and during the sound check or during basically playing, we keep developing it further, and the chaos just increases exponentially, basically. I will not go through this right now since it's not super interesting. It just calculates and kind of tries to predict the position of the thing, and this position of the rotor is then sent to TouchDesigner, and the clicks. Remember, we have one kind of impulse per revolution in order to give us an absolute estimation of the position of the thing. Is also sent to Peter into his modular system and we use it as a bass drum with many shows, which gives us automatically some kind of cohesion between sound and video and physical thing, right? Let's quickly have a look on the TouchDesigner side of things. This is what I'm working on right now. We have just installed a new light system on the thing. That's not very spectacular what we're seeing here. Basically, we have added some wireless DMX system and LEDs that can also work like RGB and have a finer addressing than we had before, etc. And I think, let me try to rotate my camera so you can see the rotor standing there in the corner. I do this. Yeah, there you can see him. And I cannot rotate him right now because I have not done the cabling. But so you see, things start out more or less tidy. And this is the current rotor patch, sadly. And basically, I mean, this is pretty chaotic, but for playing with it live, I have this also, quick and dirty user interface where I can choose different shapes and play around with some parameters. Have a little MIDI controller to control it, and let me try if I can make this a little bit more. Yes. So you can imagine the rest, I guess. again, the whole idea is to sometimes, like in case I didn't say it clearly, we know the position of the rotor and we can kind of project on the rotor like the exact wireframe at certain speeds. When it turns too fast, it just doesn't work. Of course, we could try to make this work, and if you add up all the delays of the projector, etc., you could maybe get it to work at very high speeds. I would be kind of interested in that, but I'm also not so sure if it's worth the effort, because you have to be very exact then, right? I think more interesting is if it's exactly not synchronized and going back and forth between actually working and not working, etc. I'm not sure if I should now dive into something specific, actually. I feel like I showed you kind of the overview, and maybe it is the rest is.
Yeah, I think
more
the rest
for
it's better
question.
if we just ask specific things.
Yeah, going through this network one by one doesn't make any sense. Like if somebody's
Yeah.
interested, let me know. We can explore stuff.
Yeah, sounds good. We gotta keep on going, but yeah, if you want to add anything else, feel free, of course. Patrik?
I think that's it. And again, like if somebody is interested in anything,
okay.
I would like to more go in a dialogue.
Yeah, beautiful. Thank you for sharing. As Isabel wrote in the chat, I'm sure it's something that you actually have to experience live. But even again, just seeing
it's
that,
amazing.
I'm sure again, it's doing the same thing as before in a way. It's just using kind of like the physical object itself and physics to actually display something. And the visual part from like the patterns that you send out from TouchDesigner seem to be really simple, but then the whole like rotating system and then projecting and everything, that's the complicated part. And I think that's really interesting to me, because I'm always focused on really like making complex visual systems, but in this case it's like the visual part is kind of simple, but in the end it looks really amazing and impressive and like complicated in a way.
Exactly. I think
It-
many things the colleagues said before also apply here. Like it's a lot about simplicity. It's a lot about not being able to actually predict what's happening, especially if you don't have much experience with it, and you put a line on there and are already happy.
It's a very visceral piece. I remember the first time seeing it at the set, I was, sitting very close to it, and it starts to spin, and it's heavy, right? It's got to weigh at least 80 kilograms, something, or I don't know. It weighs a lot, and it spins fast, as you say, right?
Yeah.
Three revolutions per second. And you just feel that at any point this thing could come flying into you. And so that is one, for me, that's sort of very much one aspect of that experience, right? And then there's the whole, the the really interesting sculptural with the projection and the sound. Anyway, highly recommend. Are you performing it again soon?
I think like there is something in Poland and something in Switzerland planned, but sadly I'm not able to give you the dates and times right now.
Okay.
But I'm
Okay.
So
sure
is the next iteration, like you're showing here, the patch and the setup, is that going to be performed live, or is it going to be kind of automated, or what's the mix of it?
So like I started out very automated and very compositional, just out of because you want things to be proper or something like this. But we played it so many times that I at some point threw away everything like automated, and it's really like performative and improvisational. Like
Great, yeah.
Especially because of the simplicity that we talked about, it just makes sense to play.
Amazing. Thank you, Patrik. And again, to anybody who has questions, we'll do that later in the meetup room or rooms. And yeah, for now, let's move on to the last but not least presentation by Volvox Labs.
Well, first of all, thanks for having us. I'm Ben Clowie, Technical Director here at Volvox Labs, and I'm joined by Matt Ross, Creative Technologist here at Volvox. And yeah, I'm really excited to talk about robots and Kinetics. So just before we get into it, a little bit about Volvox Labs. We're a new media arts studio. We simulate, we sculpt, and we compose with the latest media. We're driven by nature. Space is our canvas. We augment to space, and there's a robot. So we integrate the senses. Work triggers deep emotional and physiological connection. We create work that moves, inspires, elevates the human experience. So we do everything from content to creative tech and digital fabrication. These are some of our partners that we've worked with, and yeah, so we'll get into the talk. I'm going to talk about robots, and then I'm going to hand it over to Matt to talk about some of the kinetic stuff we do. All right, so first, I just kind of want to talk about robot arms in general, and then go over case study, a piece installed in New York here at Mercer Labs called The Beach, and then a very recent case study that we did for CoinWaste, and then like to do a little live demo with one of our robots in the studio. All right, so robot arms. What makes them special? I think one of the first things to me that comes to mind is precision. We work a lot with the Kuga robots, and like this robot in particular, I think it's plus or minus 0.006 millimeters on positional accuracy. So you can do some really interesting and precise movements. Also, the movements are very fluid. These robots have a really interesting way of movement. Another really interesting thing about robot arms is that their movement is dynamic. So the IK calculations are actually calculated in real time. So an interesting thing, and it can be a challenge, is that their movements are not always deterministic. Another big advantage of robots is they're very adaptable. They mimic an arm, which is a very adaptable appendage that is able to do a lot of things. And then also size and strength. So the payloads on these robots can get pretty high. I think the one we just recently did was 260 kilograms, which I think is like around 400 pounds. And there's a lot of variability in size. So we have some small robots that we use for just kind of general purpose movement type of stuff. But if you really want to make an impact and have some really big motion, there's the really large robots as well. The biggest challenge I would say is with working with robots is safety. They can be very dangerous. I always like to say they can kill you really fast or really slow. So that's always kind of front of mind when working with these robots. Then there's the programming complexity. The different manufacturers have a different way of working. We're most familiar with with the KUKA robots, but they have their own programming language for programming movements, and that's a lot of that is to do with the fact that all the IK calculations are calculated on the fly. You obviously that's necessary for you to be able to tell it to go from one point to another. From a programming side, can be sort of complex, and it also should be sort of complex because it's a complex thing, and it's a very like I said before, dangerous thing. Working with these in real time can also be a challenge. The main place you find industrial robot arms is on factory floors, and if there is real time control, it's sort of adjusting slightly based on variations in where a part is or something like that. So we're using them outside of their intended environment. So there's challenges there, and then power and mounting. The bigger robots we have take 480 volts 3-phase, which is not common. Even just to get 208 volt 3-phase can sometimes be a challenge. And then these things are quite heavy. I think the one for the Coinbase project we just did is 2,500 pounds. It could be that. I can look it up later. So we'll just go right into a case study. So this image is of a piece called the Beach at Mercer Labs. Mercer Labs is a interactive and immersive museum here in New York City. And this was a collaboration with the artist behind that museum, Roy Nachum. And it's a pretty interesting piece in the whole context of the museum. There's lots of screens and beautiful imagery, but the robot is it's the one thing that's like very much not a screen or not a light, and it's it in the museum it represents the artist. So throughout the day, it draws in the sand. It draws messages. It draws little pieces of art, and then it destroys it in this sort of violent way, where it like kind of kicks up a bunch of sand. Here you can see it moving. Just play show a little bit of the reel here. All right. So I'll just talk a little bit about the sort of content creation pipeline for something like this, and then we'll talk a little bit about the system in TouchDesigner. So there's a lot of different ways to author content for robots for KUKAs. There's a plugin for Maya, but we've had a lot of success with using Grasshopper to sort of be able to procedurally generate robot programs. And so the general pipeline is, Kirill Bezhalev, a member of our digital fabrication team, the Grasshopper wizard. He'll program the robot in Grasshopper. Grasshopper spits out a KRL file. KRL is it stands for KUKA Robot Language, and that's the programming language that KUKAs read. And so those animations get brought onto the robot controller. For those of you who don't know, an industrial robot arm is kind of two pieces. There's the big arm with all the motors, and then there's the brain, which is a controller that lives a little bit farther away, and it's got a PC in there. That's where all the IK movement calculations happen. So the animations get put on there, and then in TouchDesigner we have a way to read KRL variables, and there's a bunch of different global variables that we can read, and then you can run variables to control stuff. So the TouchDesigner side, we record those animations into TouchDesigner, and then we built a playlist system in Touch so that you can play back all those animations. And we set it up so that you can load one playlist for one day, one playlist for another day. Some playlists are a 15-minute loop. Some playlists are like a 10-hour all day sort of playlist. So some of the key learnings from doing this one, there's actually a lot of key learnings that didn't have anything to do with the software side of stuff. There's just a lot of physics and the physics of moving sand, and there was a big request from the artist to be able to throw sand. In order to throw sand, we were kind of running up against the limit of the power of the robot. There's a lot of iterations of designing the tool head, working the strength of the tool head, sort of tuning the way that the robot moves to get sort of optimal leverage to throw sand. There's a lot of writing and drawing the robot does, and using a procedural tool like Grasshopper was a really easy way to sort of bring those drawings in, and then since the system is procedural, it's kind of able to spit out the animation pretty quickly. I think, and then another big challenge was working on the feel. I think that's kind of one of the strengths of this piece is the way the robot moves. So there was a lot of internal work on authoring animations so that the movement felt right, and then there was a lot of back and forth with the artist getting things, getting the way the robot moves right, getting the way the robot throws sand right. But luckily, all the tools in the pipeline are really good for that sort of iterative process. So it worked out really well. All right, and then this one actually just happened this weekend. The team packed it up last night. This is a project. The final client was Coinbase. It's not updated here. The actual name of this piece is Coinbase Arena. And yeah, we partnered with Hovercraft Studio. So our scope for this was strictly just robot animation. So all the beautiful graphics that you see and the animations on the backboard, that was all the team at Hovercraft. They're super talented and they did a really great job, and it was really great to work with them on this project. Just to give you a sense of sort of what the robot does in this, since it just happened this weekend, we don't have a ton of footage, but here is a video of James Harden doing the All right. So yeah, the process for, or at least the pipeline for this one was pretty similar. Doing the animations in Grasshopper. The challenge and sort of the new features that we added on our system were doing a state-based animation. So I don't know if you saw in the video, but the robot changes position based on how many baskets you get, and so the experience, you could go from position 1 to position 2, and then the game could end, and then you have to kind of go back. So we created a sort of animation diagram with different positions, and this was kind of our sort of Bible for needing to know what sort of animations to author. As I was saying when we were talking about robots in general, one of the challenges working with them is that the movements are not deterministic, meaning that you can tell it to go from point A to point B, and it might not take the same path to get there. So part of having this sort of state-based animation was so that we could have animations. Let's see how to say this. We needed to know exactly how the robot was going to move from one position to another. So if we didn't have a animation going from position 3 to position 1, then we were kind of stuck. I mean, we could tell the robot to go from 3 to 1, but then we wouldn't exactly know it was going to get there, and could potentially do something dangerous. So that was a challenge, and part of solving that challenge was this sort of state-based system, and then on the KRL side, we're also checking the state. So we basically made it illegal for the robot to make a move that we didn't approve. Yeah, live demo time. Hopefully this all goes okay. I'm turn my camera on.
All right, so can everyone hear me? Yeah. Okay, so I'm just going to give a quick demo of this this state-based system. Hopefully you all can see the robot behind me. And I'm going to share my screen here. Oh, I can't share my screen. Can you not share the screen? Okay, stand by. Okay, so you guys can see my screen, yeah? Yeah, you'll have to double click to see the screen, but maybe you don't want to double click so you can see everything. But yeah, so this is the animation system, and we do a little welcome animation. And so you can see the system we built in Touch. There's this sort of these red and green dots that tells you what animations you can you know, which ones are available. Yeah, so right now we can either return to position 2 or we can activate position 3. You know what, we'll just go through the whole sequence. We'll go to 4 and we'll go to 5. Yeah, and I don't know if you can see here on the left, here's all the sort of information we're getting from the robot in real time. So just play this animation, and then we will return to position 1. All right, so that's a quick demo of the animation system that we made for the robot. And then just sort of in conclusion, you know, robot arms, they're not just for factories. They can be expressive tools. And we're very lucky to have TouchDesigner, which is, you know, a great tool that lets us bridge the a bunch of artistic workflows and you know, the digital and the physical. And with that, I am going to stop sharing my screen and hand it over to Matt.
Yes, I think we're good to go. Excellent. And y'all should be able to see the screen now. And that's great. So that was awesome. It's always great to see what crazy things Ben, Carol, see our whole team who focuses on robots is always cooking up. And I think one of the interesting things about Volvox and this, a lot of the work we do with Kinetics is you think about the robot, and this is one massive piece of hardware that is doing these giant moves that you have to be really, really careful with. Not that you don't have to be careful with other things, but it's an interesting thing to look between that and then a lot of our other work with motors, because as opposed to having one giant thing that is non-deterministic and is really, really hard to program, you can switch over to a world where you're working with servos that you can control PWM, and a lot of your challenges end up being challenges of scale. So I want to walk us through 2 case studies of projects we've done over the last year, and then kind of talk through some of our learnings and our process and all that good jazz. So the first case study is for a project for the car brand Infinity. And a lot of clients will come to us, for experiential marketing purposes. So in this example, we have Infinity who's launching a brand new car, and they wanted to build a series of installations that highlight specific elements of the car. So the Kinetic installation, as part of this 3 installation series, involved building this sort of kaleidoscopic room of mirrors. I have a really corny name for it. I call it a Kinetic Kusama room because it's like you're stepping into this room where everything's reflected, except in this instance, you have a lot of extra motors and we have a whole LED um, system built into it. And based on where you stand within the structure, it will basically activate this color wheel function. So, there's the whole wheel of color, as we're familiar with it, that is mapped across this circular interior of this mirror room. And depending on which way you walk, a sensor is basically tracking your movement and animating the mirrors and changing the color schemes. So here's a little GIF, you can kind of see it in action. And it's a really, really nice way to play with light, movement, and space. And I think one of the things that we try to think about is combining small, subtle movements with, unusual space or non-traditional space. And, you can take a lot of really small movements, like just a mirror moving ever so slightly, and the movement of an LED color wash or gradient moving just a little bit. But if you build that at scale, you can end up with something that can be really interesting. And this technique of putting mirrors on motors is something that we're really, really big fan of. And another thing that we try to do at Volvox is repurpose things. So this installation currently lives at our studio. We just decided to make it really tall now. So this is me taking this right before the presentation. We currently don't have the LED part of this installed, which was a really nice part of it, but it's still really nice to see this at scale. And before I go forward, kind of digging into how we built this project for Infinity, I want to talk about one of the most important parts in building a project like this, which is having a good team. And I think that is one of the really special parts of Volvox Labs, and one of the things that makes projects at scale like this work, because you look at something this big, and this is a project like this is a contribution of a lot of people. There's a lot of motors, a lot of wiring, a lot of CAD drawing, a lot of motion graphics, a lot of things that need to come together in usually a very, very short amount of time. And I think what I find really special about Volvox Labs is the ability to take the constraint of maybe you're dealing with 60 different motors moving at the same time with a small timeline, and everyone is able to adjust and kind of figure out the best path forward. So this another really nice part of Volvox is sort of a legacy of doing Kinetic projects. So this Infinity project, which was done last year, actually evolved out of a project from, I think, 2016. So this is a project for, why don't I just go to website? And so this evolved out of a project called the Microsoft Lounge, and it's a very similar idea to the mirrors, except the basically it was undulating the Microsoft Windows logo. So you can see we have these small individual pieces that are all kind of working together, and you have the back lighting, and it's a very, very similar technique to what we did with the mirror wall. So it was all a TouchDesigner system. All the animations are also programmed in TouchDesigner in real time, and we took a very similar approach to animating our Infinity project that we did with this, in that every motor basically is represented as a single pixel. We'll get into that a little bit further, but I just wanted to show you this project because this was a really, really, and I think, special project with Volvox, and it's been cool to see this technique evolve over time when a lot of the base mechanisms are really similar. You can see how things can be reused. This technique of using these specific servo motors has served us really well. And in fact, the servo motors that were in this project are the same ones that are hanging in our studio to this day. I want to talk a little bit about those motors. We use the Ultramotion A2. Wait, no, sorry. I don't know how to use slides. So we use the Ultramotion A2s. They are definitely not the cheapest. They are, but what they are cheap is reliable. And that can pay a lot of dividends because these have been in production for, we're approaching 10 years. They definitely need a little bit of WD-40 every once in a while, probably more than we actually give it, but they are really, really reliable and really easy to program. We're able to use an Arduino and just send a simple PWM signal to it. So, the same mechanism that you would use to program a simple servo, one of those blue ones you get with an Arduino kit, we can use the same technique to program a linear actuator. So I wanted to show some of the CAD drawings of this sculpture, and you can kind of see we try to approach the way we build software and hardware in a really similar fashion, where everything is very modular and fits together in a way that allows you to parameterize things. So we love building things in Grasshopper. We love building things that can be extensible and be reused. And so you can see that this whole sculpture, while there are 60 individual mirror points, it's all replicated. You have one entity, one small box that our fabrication team built. But when you're able to replicate that and build that and modularize that, you can expand that into a big structure that lets you be really flexible and explore a lot of different types of forms. So you can kind of see this thing from the top. And I wanted to show some early explorations with this technique. I have this video on the right that was, I think, 2 years ago, the first time I just got these Ultramotions plugged in. And then on the left, we have a really, really early iteration of the mirror wall when, we just wanted to test out as a proof of concept that this would look cool. And it did. So I wanted to show some early development cycles of getting these mirrors moving. It is a step-by-step process to get an installation to that show-ready process, and you're doing the same thing over and over and over again. And so, for example, you can see on the left, we started programming and doing our proof of concepts about movement as soon as we had one part of this ring of mirrors up, because this is something that we're going to have to replicate 10 times, this specific discrete unit of programming, which is two mirrors next to each other. So we want to test out things before we put the really nice mirror that we paid for, and we don't want to scuff up. Let's do as much testing as we can before we get to that process. I want to show on the right over here also, this is sort of how we're interfacing with the motors. We have our copium power supply, which goes into this breakout board that we custom made for that Microsoft project. So that's actually sitting as an Arduino Uno hat, and that takes in the power and sends out power and PWM to each of our Ultramotion servo motors, and that can do up to 8. And I think that's another thing to talk about when you're doing collaboration like this, where you're building a huge structure, where your design of your software and the limitations of what hardware you're using ends up being a physical factor in how you're designing and how you're installing. Because we had a limitation where one Arduino controls 8 different motors, so that informs how we lay out wire runs. It informs how we lay out power. It informs how we are going to construct this structure in that, we're doing 8 at a time. This is a really simple wire diagram. I think this also speaks to another point I'm going to make about optimization, where sometimes on timelines you don't have time to make the CAD drawing that you want to make. And the thing that you need to do is communicate to your coworkers and the people that you're working with the information that you need to get across. And this was sort of our integration guide for when we were on site, since we had a really quick install, and this served us really well. This image was made by one of the technical directors of this project, Claude Dor, who's our director of production, and he was in charge of basically designing all the lighting systems and doing a lot of the power calculations for this. So kind of gives you an overview of, you have a specific unit of functionality, which is a motor moving, and you start to replicate that out and modularize things. So if we needed to ever add on more mirrors to this, we could. If we need to subtract, it's not necessarily something that our fabricators, or programmers, or integrators would really think about. You have discrete units that you're just replicating. So I want to talk a little bit about show control in TouchDesigner. So this whole experience was controlled via a TouchDesigner patch, and the idea is that you would walk into the middle of this room, it would detect where you moved, and it would trigger some lights and movement. And when you're working with Kinetics, like you're moving with anything, you want to think about what is a trigger. What actually defines the beginning of an event, the beginning of a scene, and do you want to be switching scenes haphazardly? You don't want the mirrors to be doing a whole wipe across the entire structure, and then get an accidental trigger, stop that animation, and then freak out. Because as my coworkers will attest to, when you hear this thing freaking out, if you're sending it 2 different animations at the same time, it can be kind of scary. And it's really important to be really declarative and really specific with how you are telling all your motors, I need to do this at this time. And TouchDesigner is also really useful because you're able to build a really sophisticated system to control all these motors, but we're also interfacing with a DMX lighting. We're interfacing with different camera sensors, a bunch of other things. And that's why it's really important to have a specific source of truth about state. We love using extensions here and doing a lot of stuff in Python. And for us, making sure that any change you're making to your system is a safe one to make, and that you're not going to have 2 different or 3 different things that your motors are trying to do at any one time. That is the really important thing to think about, is how are you telling your system to do one thing versus another, when it's really easy to throw in a noise chop or a noise top in TouchDesigner. But sometimes when you need to be really specific, it's a very important thing to be very careful about. For animation, it was really important for us to, one, be able to visualize what we were programming, and also give us a way to program things really, really easily and really quickly. So we had multiple people working on this project as well. So I was building a lot of motor control systems. Our creative technologist, Javier Cruz, was building a lot of the animations, and we were able to kind of jump between different domains really quickly because of the way we designed it. You think about the mirror, each linear actuator has the ability to go completely in or completely out. So we basically map that value between 1 and 255, and which is the max and min of a servo. And you can take the black of a pixel, say that's 0, and the white of a pixel, move that to 255, and you basically have a way to control the movement of a mirror like a pixel, and you end up having a system which is very one-to-one with how you're programming things in TouchDesigner with how things look in the real world. Another important thing is when you're working with a client and creative directors that are maybe not super familiar with TouchDesigner, how do you communicate with them what animations you're building? How can you bring other people into the process? And doing things really visually and treating a physical object as a pixel is a really, really good way to do that. And then finally, I am a huge animation comp stan. I think Greg is still on here. There's a lot of animation comp lovers here. If anyone ever wanted to update it, and it is a really, really powerful tool to be declarative in how you program your systems. Like, I mean that you can have a lot of different ways of animating something like a motor or an LED light or any number of things. But when you have a very specific animation curve that you've generated, it gives you the ability to, take something like a generative trigger where it's, you don't know where a person is going to move in a specific part of the room or when they're going to trigger. Okay, let's start the show. But you can generate a lot of curves ahead of time in animation comp and use that in a very specific way to build out a show. Finally, something I was trying to talk about is this idea of extensibility, where we want our process on the software to be really similar to the way that our designers are thinking. Ben was talking about how we use Grasshopper, and if you say the term parametric design anywhere in our office, you'll have a bunch of people kind of like stick their heads up, and that is something that we really try to replicate within our code. I'm a huge fan of replicators, and so one of the ways that I built the system is so that you can be dynamic with how many mirrors you're working with and your arrangement of your outputs. So you can see here we have this little snippet of the network, and that is basically the commands that are being sent out to the mirror, and these are basically just positions. And I have my replicator kind of basing everything off of a prop, and I can dynamically generate however many positions I need to send out to the motors. And this design is a constraint of the hardware that we have. And one of the main tricks of things is balancing your hardware constraints, your design constraints, your fabricators, and what you actually need to build in your software. And when we're on site, at 5 a.m, putting this thing together, the way that you write your code and how it's going to communicate with each Arduino is going to determine how you and your team members are wiring things up. And that's why just communication between our team is one of the most important things that we strive for, because everything is super connected in an installation like this. I wanted to move on to another installation that we worked on last year.
I think it would be great if you could keep it short, because it's been going on for a while.
Yes, I'll keep it quick. Thank you. Longer than I want to. So this is for a client named Product. They were launching a new scent, and they wanted to have an experience where there were these columns that emitted these bubbles, and when you pop the bubbles, they would pop with smoke. And this was a really, really fun experience to build. So because just having TouchDesigner controlled bubbles just seemed like a very fun and silly way to do it, but I think the end product ended up being kind of elegant. I want to bring a huge shout out to our director of physical design, Zia Zhang, because this whole thing being possible was really because of her ingenuity. We started from basically nothing in an R&D phase, guessing, is this possible? And she was able to, this is what her workspace looked like for a couple of months, and it was a really, really incredible thing to watch. So I really just wanted to talk about what an amazing accomplishment it was that she was able to do this, because the TouchDesigner and hardware side was actually pretty straightforward. But I think the way that we built things is a really really nice way to kind of balance things. So basically, you have your bubble wand that you get in a thing of bubble juice when you buy the Party City, and we built a 3D printed version of that and an automated servo system that allowed us to do that on demand. That process of dipping your bubble wand in the bubble juice and blowing, we used a 3D printed wand combined with a 5-volt servo and a fan to basically replicate that process of you blowing into a bubble on command. I wanted to show you this picture because it brings me a lot of joy. And this is what a lot of time, what the process looks like, just kind of figuring things out. This on the left is the hardware that actually sat inside of each column. It needed to be waterproof because it was submerged in a vat of fog for 3 days straight. And we really like using these weather pack connectors, which Ben actually showed me. These are a great way to do waterproof connections and have that in a nice little junction box, and you're pretty much good to go. And here are some just process photos of us getting everything working together and kind of the inside of these really nice components. And to just kind of quickly go on the TouchDesigner side, I think it's really important whenever you're communicating with something, and these were all Arduino-based systems, but we're also working with a DMX fog machine, also working with some other hardware. How do you abstract every little piece of your system, so that it can just be a stop and start button? And thinking about, what references you're making, what are you doing in a code? I'm gonna try and not use the run command because I don't know where that's happening. And being really careful with how you order things and how you basically know, okay, I can get an acknowledgement from my Arduino that my state has changed, but I'm not going to get that acknowledgement from a DMX fan. So, some things you can get an actual piece of code and a thing saying this is going to happen. Other things you just need to send a code and move on with your life. This was really based off an animation comp. It works really well for something like this, where I have maybe 6 different DMX fixtures or Arduinos or anything that I need to use. But you can use the animation comp to basically lay out, I need one thing to happen after another, and that works really well. And just like with the Fin project, everything should be really simple in that everything's identical. If you have 5 Arduinos in your project, everything should be running the same code. If you need to throw one of the Arduinos out or something breaks, it should be really, really easy to do that. So final learnings is premature optimization is the root of all evil. Your people watching your piece are not going to care if you have a messy network. They're going to be really happy if it looks and works really well. Make a user interface for yourself, and then make sure that the user interface actually works. I think probably the biggest thing is every little piece should be replaceable. Whether it be one of the AV pieces of AV equipment, like a data extender or code in your code base or a motor. Finding out what are all the individual things that can break and figure out how can I break them myself. If I need to replace them, how can I do that? And so I think it's a really important thing for us, and do everything in TouchDesign if you can. So that is, I know we're running for time, so I will just leave it there, and thank y'all.
Wow. Damn, that was a lot of input and beautiful, beautiful projects. And you can just see it on the chat. People are very inspired. So it's yeah. Thank you for that overview. That was absolutely beautiful. Yeah, and I feel like all the robots in the beginning. I was like their arms. I was really amazed how quickly they seem very animal or lifelike. I mean, we probably just did a really good job on it, but especially the drawing and the sand one, it just really feels like this animal, which is kind of a weird feeling. But yeah, it's incredible. And yeah, using bubbles in a project, I've never heard of anything like that. You know, like controlling bubbles with TouchDesigner, so it's very unique and great job, guys.
Yeah, I never foresaw that when we first designed TouchDesigner.
I bet.
Thank y'all so much.
Cool.
No,
So-
like
Yeah, Greg.
a lot of the themes of the presentations is kind of interesting because it's a lot of it is designed around transitions between states of things, like a patch and then you want to go to another patch and then another patch, and it's easy to just say, oh, crossfade everything, but you can't do that completely, and you don't want to do it completely. So you're getting into more and more complex scene managements where you have to shut things down and then crossfade some things and then delay and then crossfade other things and stuff like that. And I think, you know, everybody's work, even from Boris's work and Patrick's, there's a lot of kind of like management of scene to scene transitions.
Maybe I can add to that, but yeah, I totally agree, and I think this is also why Boris and we are always so fixated on creating a system that you don't have to necessarily go from state to state. It is just a system with parameters, and that is essentially the one state that it's in, and yeah, you just flow from one state, sort of say, into the other. But I agree that especially with these physical kind of things, just switching to a different state is different than using an LED screen, for example, where it just responds, you know. And with these physical things, you always have like moments of inertia, whatever, that's just make it impossible to just be like, bam, and now we're gonna do this. And it also feels weird, I think. But yeah. By the way, really impressive presentation, guys. Super beautiful work, and thanks for all of the insights. Really nice.
Thank you. Likewise, yeah. Everyone's presentations so inspiring.
Yeah.
Hope to catch all your work in person one day.
Yes.